Hello and welcome to today's HealthITAnalytics.com webcast sponsored by Verato. Case study, Solving Patient Matching with New Gold Standard EMPI Technology. I am Lindsay Carlson, Vice President at Xtelligent Healthcare Media and moderator of today's webcast. We will begin with a presentation by our speakers and conclude with a question and answer segment. Audience members can submit questions at any time during the webcast using the question tool to the left of their screens. The presentation deck is available for download under Resources on the left-hand side of your screen. For all technical matters or difficulties, click the Help icon at the top right-hand corner of the screen. A recording of the webcast will be made available following this presentation. First, I'd like to thank our sponsor, Verato. Verato enables healthcare organizations to manage, match, and link their patient data with unprecedented ease and accuracy, scale, and performance, and at the lowest cost. Verato offers two cloud-based patient matching services powered by smart referential matching technology, the new best-in-class EMPI solution, and a powerful plugin that eliminates duplicate records. With that, I would like to introduce our speakers, Dave Bonowitz, System Integration Specialist at Axia Women's Health, and Mark Leroux, Chief Executive Officer at Verato. Dave Bonowitz is a Systems Integration Specialist at Axia Women's Health, the largest integrated OBGYN healthcare provider in the U.S., where his responsibilities span master data management, data architecture, data integration, data migration, data warehousing, and data analytics, as well as developing and operating Axia's Enterprise Patient Index, EMPI, and building HL7 interfaces. David has also architected and built a data analytics reporting platform, built a KPI and dashboard system, helped a leadership role working with a premier global analytics vendor to build expanded and analytical capabilities, and built an integration platform to create a single source of truth. Prior to working at Axia, Dave held senior positions at IT and software consulting companies, including senior consultant at Turnberry Solutions, lead architect at OnTrack Consulting, and systems architect at Simpac Inc. Mark Leroux is the Chief Executive Officer at Verato, a leading provider of cloud-based patient matching and master patient index services powered by referential matching technology. He was formerly at MicroStrategy, a business intelligence software provider, for 14 years, where he was the Executive Vice President of Products, responsible for product strategy, product marketing, and competitive intelligence. Prior to MicroStrategy, Mark was with Ernst & Young for 17 years and left as partner, responsible for all technical consulting in the East region of the U.S. Mark holds MS and BS degrees from MIT in electrical engineering and computer science. Mark, I'll now hand the floor over to you.
Hi, Lindsay. Thanks a lot. And special thanks to Dave for being on this webcast with us. It's an important topic, and having somebody so well versed in it as Dave and Axia is a real bonus for all of us to hear about their experiences. Let me start off this webcast, though, Lindsay. I'm gonna set up the problem, if you will, a little bit around what is the problem of patient matching and why is it such a difficult problem now, and then I'll turn it over to Dave, and he can tell you about the real world experience at Axia. And then I'll finish up the presentation with a better rounding out of how does this technology work at a deeper level. And then I think we'll close out the whole story. And as you said, we'll have the Q&A at the end. So everybody, feel free to, and I encourage you to send in your questions over the chat feature. So the agenda, as I just mentioned, I'm going to give you a brief overview of Verato. Then I'll talk about the challenge, pass it over to Dave, and then wrap it up. So let's talk about Verato just from 2 slides. This is my brief commercial, if you will. Look, Verato is a software company. We're located here in the Washington, D.C. area. In fact, I'm broadcasting to you looking out the window at an overcast day, but it's finally turning spring here on the East Coast, I'm happy to say. As a company, we were founded in 2012. We're venture-backed, so we've got quite a bit of venture energy behind this company, which is funding the very expensive development that we've undertaken in order to bring this new technology to market. And it is all about this new technology called referential matching, which is based, and I'll explain that in detail a little bit later on, so I don't even need to go into much detail for you here. Suffice to say, Verato is the only company today with this technology in the market. solving the MPI problem. And then a quick look at some of our customers. You can go to our website and find out about a lot more of them. But some of the customers, they encompass very well-known healthcare providers, Axia being one of the more interesting ones for the breadth and scope of what it's accomplishing using our technology. But you can see several other ones up there too, Intermountain, Texas Health. We're also proud to say that we're serving many of the nation's largest HIEs, the health information exchanges, largely because their patient matching problems are, in essence, the hardest in the country. The diversity of inputs and the diversity of populations they have to manage truly stresses MPI products, patient matching products, right to their limits. And recent news about Verato, the Pew Research, independent research organization, after a 2-year study concluded that referential matching is one of only 4 technologies that they deem having the possibility of solving the nationwide patient matching problem for the country. And that was in a report that was just released last year, the middle to end of last year. Healthix dropped their IBM Initiate product, replaced it with Verato. Northwell has done undertaken a very aggressive program to annihilate duplicate medical records, and Verato's AutoSteward product is right at the core of that strategy. And of course, Axia Women's Health that Dave will be talking to you about. Let me set a little bit of background here, a little bit of foundation before I turn over to Dave. For those of you who are deeply invested in patient matching and MPIs, you know all this stuff, but on this call there are undoubtedly a number of people who don't have the proper foundation to understand what the challenge that Axia was undertaking. All organizations, whether they're healthcare or not, if they're dealing with people, so this includes retail, financial services as well, if they're dealing with people, they're basing all of the data they have about those people on a demographic profile that they have of them. And it's often highly siloed. In healthcare, we've got a picture of a patient that exists in the health records system. We have a picture of the same patient that exists in the laboratory system, maybe another picture in a billing system or some other system. And the role of the MPI, whether it exists as a standalone EMPI product or it exists embedded within your EHR product, the job of that MPI is to merge those identities into the same single person, so that you have a 360-degree view of the patient, whether it's a billing view or a laboratory view or a medical records view or a social determinants of health view. It all should be applied to the same person. And we know that's the task, and that task is serving many masters today. Traditionally, it serves the clinicians with complete patient records. It serves the revenue cycle department so that they can optimize the billing and the receipt of revenue. It optimizes the CMIO's or the CMO's job of ensuring patient safety. More recently, and in the recent past, you see additional use cases being applied to the MPI, evidence-based interventions, clinical quality measures to be submitted to CMS or for other quality ratings, and now new population health analytics. So this MPI and its ability to consolidate all the information about a common patient is quite important today. Now the real challenge is that very few MPIs have a complete and unified view of patients. In fact, what's more typical is that you'll have multiple versions of the same patient within the MPI, and certainly within the source systems you see on the right and the left that are feeding the MPI. And it's this duplication, this issue where you have two people in the EMPI representing the same person, but the EMPI doesn't realize that it's two different, whether it doesn't realize that it's the same person, is very problematic for a lot of reasons. And the opposite of duplication is where you have overlays. You have two identities that are indeed distinctly different people, but somehow the MPI has been fooled into thinking that it's the same person. And it's a much worse situation, obviously, because you can perform dramatically incorrect medical procedures on a person if their medical records are combined with somebody else's. Now, this issue of duplicate records has been around forever. No technology is absolutely perfect. No human being's interpretation of demographic data is 100% perfect, and we learn to live with it to a certain extent. Now, the reason why all of this duplication or overlays occur is because there's an inherent error rate in capturing demographic data. In fact, all of our analysis here at Verato, when we do proofs of concepts for our customers before deploying, we look at people's MPIs from top to bottom and measure them against our reference database. And even using conservative interpretations of our analyses, we've determined that upwards of 30% of all demographic data that exists in MPIs today and in EHRs is either out of date, errored, incorrect, or missing crucial data items to the point where it can't be matched correctly with other versions of the same person. And this happens because, as I said, a lot of data gets out of date, names change, addresses change, phone numbers change. But there's also situations where there's very ambiguous identities, two people whose information is extremely close, juniors and seniors, twins, the ambiguity that occurs with cultural naming conventions and hyphenations and apostrophes. Data errors, typically at the data capture point, when you're at the registration desk, spelling errors or transcription errors or homonym errors. And finally, a lot of people, for reasons of privacy or laziness, often put in default information. I was born on January 1st, 2001, 111, or my social security number is 111, 111, 1111. So these things are the things that infect an MPI and make it very hard to map identities together correctly. And in fact, in the example you see on your screen there is a pretty classic one where somebody, this Cat Smith, looks like she got married, and the next Cat Smith on Main Street got married and became, next time she visited the hospital system, she was Catherine Jones, so not Smith but now Jones, and had moved. And so this is a classic situation of name change with a move. Happens to 12% of the population every year, so it's a compounding problem and a never-ending problem. That's the most obvious kind of problem. And this problem exists, and it's existed for a long while, but the really ominous thing for all of us to recognize is that the problem is not getting better, it's getting worse. And in fact, in two very published and third-party surveys done, one in 2008 by AHIMA, and then another one in 2018, 10 years later, done by Black Book Market Research, shows that the average duplicate rates have degraded from 8 to 12% to now upwards of 18% across the range of health systems. And these were a fairly representative cross-section of health systems in the United States. So the question every one of us should be asking is, what's going on here? Why is our technology working worse and worse over time, not better and better? Because if this trend continues, like this gets to really a catastrophic conclusion. Well, what I would suggest to you is that the reason why things are working worse and worse is not because the technology is getting worse, it's just our application of that technology is getting more demanding. And Axia is a perfect case of this. They've got dozens of sites now that are intaking patients with different registration processes across the state of New Jersey, I believe, wherein every place has to work perfectly well in order for the traditional MPI technology to work adequately well. Let me give you an example of what we see happening with MPIs. Today, the things that are feeding MPIs are typically EHR systems, laboratory systems, imaging systems, all the clinical systems that are kind of tightly tied together, often in one single EHR product. And so they all can be managed and governed pretty rigorously, if not from a single vendor, then from a single set of people responsible for those systems. And the people that are using those systems are relatively constrained. The patient records are being used by clinicians, the revenue cycle people are using the billing records, and the patient safety people are doing analytics on the outcomes. It's been a relatively contained environment for a dozen years or more. The inputs have been relatively fixed, the consumers are relatively fixed, and everybody has gotten a sense for what can be accomplished with existing technology. But what has been happening over the most recent years is the number of feeds going into the MPI are growing radically. And in fact, what you see now is new EHRs are being folded in through M&A activity. HIE interactions are hitting the MPIs, feeding it and being fed by it. telemedicine initiatives, biometric initiatives, social determinants of health and IoT projects, and even the consumerization of the patient with CRM products are now both feeding and extracting data from the MPIs. And the users of those MPIs go beyond those systems I just mentioned to include portals and personal health record apps, new strategies around the consumerization of healthcare, risk management applications, M&A activities, personalized medicine. So the consumers and the sources of information are growing at a rate that are causing the inherent error rate of the MPI to grow exponentially. And in fact, if I left you with nothing other than this in this conversation, is that there's a fundamental truism about data and about demographic data in particular, that the more data you feed into it from the more diverse sources, the greater the chance of errors being injected, and these errors then compound once they've been injected into the system. And this really speaks to why we're seeing the performance of traditional MPIs degrading over time rather than getting better. They're being asked to do more. And in fact, the owners of these MPIs are also finding themselves in a particularly awkward position, because not only are their MPIs exhibiting more error rates than ever before because of all these new inputs, the fact that this MPI is being used for more use cases means that there are more people scrutinizing the output. The errors, the imperfections of the matching system are much, much more visible than they've ever been in the past. In fact, the portals and the PHR products, the patient now is looking at their data in your database, and they're asking, why are my records incomplete or incorrect? The CEO is looking at the data that's in there and saying, why are the patients seeking care elsewhere? Why are my consumers, why are my patients losing faith in my health system? It's not because of the health care, it's because now the perceived sloppiness in records management. The general counsel is wondering how did we show another patient's data to this patient, right? They're worried about HIPAA violations and liability. The CIO is worried about merging this data with other databases. The CMIO, who's interested in personalized medicine, is wondering, why is this clinical picture so incomplete and insufficient? Why can't I roll out a social determinants of health program? Because I can't match the data up to the correct patient. And finally, the CFO is wondering why the operations are so expensive. Why are we doing so many redundant tests and procedures? And all of these new people who are becoming users, or at least scrutinizers of the MPI system, are going to be asking questions that the MPI never had to answer before, back when it was just serving revenue cycle and the clinicians. So the storyline here is that the existing MPI technologies based upon probabilistic matching have become and are proving to be too inaccurate, with 18% duplicate rates. They're also proving to be very brittle. They can't accommodate new use cases and new sources easily without complete retuning. They're costly, not just because of retuning, but they're costly just to operate, as on-premise software typically is. And then for large institutions, large healthcare institutions and HIEs, it doesn't scale. Traditional MPIs using their traditional technology don't scale well, and they're labor intensive. Ultimately, the storyline with conventional MPIs using this technology called probabilistic matching that has been around for 20 years have reached their end of life. And it's had a good run. It's had a 20-year run, but they've reached their mathematical limits, and they're just not going to get any better. And so referential matching, the thing that Dave's going to talk to you about in a few moments in his application of it at Axia, is the next generation of the technology. It is much more accurate right out of the box. Because it's more accurate, it's much more nimble. You can add new use cases to it, add new sources to it, without completely retuning it as you would with probabilistic matching. And because it's cloud-based, it's highly cost-effective, it's scalable. I can't really prove to you why, because this is not a technical presentation, but inherently it's much more scalable to literally hundreds of millions of identities and thousands of sources without degrading its accuracy. And the other really interesting and useful thing is that it operates in real time. It's not a batch process. It operates at the speed of portal interaction. So ultimately, if we want to solve this next generation set of problems and challenges with patient matching, you have to look at a next generation technology. And that, in essence, is what Axia did. They challenged us quite vigorously to prove ourselves to them before they considered using us. And with that brief introduction, what I'd like to do is introduce David Bonowitz once again to take over this middle part of their presentation. Go ahead, Dave.
Thanks, Mark, and good afternoon, everyone. Over the next few slides, I'm going to tell you about how Axia Women's Health was able to overcome our patient matching and merging challenges by leveraging all that stuff Mark just told you about. But first, I'd like to tell you a little bit about Axia Women's Health. We're a multi-specialty provider group focused exclusively on women's health care, and we were founded in early 2017 through the merger of two similar-sized groups, one from Pennsylvania and another from New Jersey. And once we combined, we became the largest integrated provider of women's health care in the U.S., and we have plans to continue growing from there pretty steadily into the future. So as we continue to grow, we know there's a few things that we need to focus on to make sure that we're able to accommodate our ever-growing patient base. Patient care is paramount to us, so we want to make sure that we're always moving towards improving patient care and having accurate medical records. And as we started the process of combining our PA and New Jersey groups together into one, we anticipated that there was going to be a significant need to clean up the existing databases, of which there were approximately 25. Our strategy was to combine those databases together, so that way we would be able to have a more complete medical record available at our providers' fingertips, and also to decrease our IT infrastructure and training requirements. And our larger vision of what we're trying to do at Axia is to build out a continuum of women's health care that's going to allow us to really leverage the multi-specialties that we serve to provide a one-stop shop for all of our patient base. Why we needed a referential matching system was obvious to us because as we continued to grow over the years, we noticed that there was a trend of duplicated patients that needed to be handled within our, even just the one database that we had. And previously, before merging into the Axia database, we already had some experience using algorithmic matching that was becoming a bit risky. At the size and the demographic spread that we have, it was a certainty that we were going to have people with very similar demographics, including same first, last date of birth, similar addresses. It became very, very risky for us to make assumptions about what we were doing. And in addition to that, we are being focused on women's care. A lot of our patient base very commonly has name changes, address changes that makes those types of algorithmic matching systems less effective. And our original solution to this was to throw people at the problem. So our help desk was becoming inundated with merge requests from care centers who were reporting that our medical records had become fragmented. So we knew that in a very short period of time, we need to focus on deduplicating all of the information that existed in our current database. And we needed to find a way to make sure that as we continued through the M&A processes to bring more databases into our system, that we weren't just going to recreate the problem that we had solved previously. And then we knew that duplication doesn't always come from M&A, it just happens, and we want to try to find a way to reduce the amount of duplication caused by our staff. And we needed to do this kind of in a hurry. We had a pretty tight deadline that we needed to meet, and fortunately we were able to do so by leveraging Verato's system. We adopted a three-step approach in order to make this happen. The first was to prove the concept. A lot of people had doubts that this was even going to work, and I was one of them, honestly, in the beginning of this, because we had so much experience with merging databases so far that it becomes easy to think that you're not going to get it right, or there's no possible way to have the high yield that we're going to need to do this correctly without having that human interaction. So we would need to prove that concept, and then after that, we would need to clean up everything that's in our existing database, and then and only then can we introduce what we call an organic process, which is near real-time monitoring of all of our patient information to catch and eliminate duplication within our systems. So proving the concept involved a number of technical challenges that we needed to overcome, such as how would we integrate this with Verato's system? What tools need to be in place between our docs and the Verato cloud-based services in order to make this all happen? Can our EMR system support this integration? And we were told that HL7 messages were a good start in terms of how to integrate these pieces. So we had to talk to our EMR vendor to figure out that they can in fact support the merging capacity via an HL7 message. And then we had to make sure that we were going to be able to speak the language that the Verato system needed in order to bridge the gap between HL7 and the cloud MPI. Once we were sure that technically it was possible from a component standpoint, we had to start really thinking about the workflow of how this was going to go. And when you're messing with patient information, you want to be extra safe and make sure that you don't accidentally merge wrong patients, but knowing that this is the real world that we're in, accidents could potentially happen. So we wanted to protect ourselves as well by building a very thorough logging and auditing system to make sure that if we did something wrong, we can undo it, or at the very least understand why it did what it did so that we can prevent it from happening again. And then we were going to run lots and lots of tests and put many eyes on what was happening to make sure that what we were selling was actually what was being delivered. So to perform that initial cleanup, we first had to provide Verato with a full data dump of every single patient that we currently have. We provided this to them in a data file that they then processed on their side and ran through their system to go ahead and tell us if there's any duplication within our database. They provided to us the file that contained information pointing out all of the duplication that we had in our system, which was just significant. Probably about 10% of our patient record count was duplicated. The next part that we had to figure out was how to determine which account we wanted to keep versus which one that we wanted to merge. And I would say that this was probably the most challenging part of the project for us. And then we needed to test a lot. So we did a full test of the entire thing on a copy of our database, and we enlisted the help of some colleagues here in our office, probably about a dozen or so, to go through and review everything that had happened to make sure that nothing appeared out of the ordinary or incorrect, and then to get kind of feedback and sign off on that feedback from leadership before we would continue on to implementation. Now this graph here shows what the effect of the initial cleanup was on our duplicated merge requests that we were receiving in our office. So the timeline there is from the inception of our EMR all the way up through, looks like about September of 2018. And we began this process in the beginning of 2018, when you can see that there's a dramatic spike in terms of how many duplicated patients are being reported to us and that our help desk is having to struggle to process and keep up with. And the number spikes up dramatically in April to the highest point that it had ever been. And it was soon after that, in April, that we enabled the Verato system to perform that initial cleanup on our database. And the results speak for themselves. That the dramatic decrease in duplicated patients being submitted to us was felt by everybody throughout the organization. We had happier providers and staff, and our help desk was sure relieved to not have to be burdened by all of those duplication requests. But we couldn't stop there. We had to move into preventing this from happening going forward. So we began to work on the organic flow to catch in near real time this duplication and merge it away. And the way we approached this challenge was we began trapping organic data. So real data from users every single day after we performed the initial cleanup was being put into a queue for us to use to test with. This gave us the ability to do real-world testing in a simulated environment to help eliminate the possibility of us being surprised when it came time to implement this in our production system. And we tested a lot of different workflows and processes and determination mechanisms to make sure that we had tuned this system just right before we went ahead and turned it on. And as we continued to figure out individual pieces of how this happens, including what happens if a new duplicated account is created during the day versus what happens if somebody at a care center level manually merges patients, and how do we keep that synchronized with the Verato system. Every time we felt that we had perfected one of those components, we went ahead and enabled them in production one by one until we had completed the organic process. The organic process results shows that in April there, you see that the initial cleanup that we performed deduplicated approximately 125,000 extra accounts in our system, dramatically improving the accuracy and cohesiveness of our medical records. But what's most important to me on this slide is how eclipsed the Axia merges and help desk merges are as a result of the Verato process. You can barely see them prior to April, and you can't see them at all after it. So in working through this, we were able to learn a number of things about the workflows that are being used at our care centers that we didn't quite expect. As it turns out, people create duplicate records all the time, and the reasons that they do it can vary. It can be accidental, or it could be a workflow-specific thing that they're doing that we're unaware of, that becoming aware of it helps us help them find a better workflow. And we can also now identify who are the specific sources of duplication so that we can reach out to them and figure out better ways to prevent duplication from happening in the first place. And another unexpected benefit from this was the overlay detection, which, due to our haste in the need to implement this solution, we didn't even think about the idea of what would happen if somebody was to go into an existing patient account and, in error, overwrite it with a different patient's information. And we see that that happens occasionally as well. So the future for us with the Verato implementation now is, since we have something that works, it's in place, it's doing its job every day, we're free to go ahead and expand now without the fears that we once had about creating rampant duplication in our system. And we also have improved ability to integrate with third-party systems such as labs and hospital systems. And this also has a good impact on our analytics process. In the past, it was difficult for us to accurately report on what I call the patient life cycle. Being multi-specialty, we have patients who go to imaging centers, go to some of our fertility centers or our OBGYN centers. And since they are loosely coupled, there's a possibility that a patient could have an account at all three of those places and they hadn't been merged together correctly. So being able to determine things such as where a patient's entering, who is referring to one of our other expanded care centers, typically how long do they stay there before they transition back to another, were all things that we were not able to answer with any degree of confidence due to the fact that the accounts weren't all synchronized. But now that they are, we can answer those questions more accurately than we ever could before. And with that, I'll go ahead and pass this back to Mark.
Thanks a lot, Dave. That was great. And a handful of slides, simple. Axia's simple story just jumps off the screen. I mean, that's a great success. And you know, frankly, that's what we're all about. That's what we're trying to do, is to take this issue of patient matching off the table, to turn it from something that's incredibly hard and risky to something that's much easier and much more automatic. But it sounds like you navigated yourself through that in a really fast and predictable path. Well, look, we've been talking about referential matching, so I thought I would do just a handful of slides to explain to people what referential matching is, contrast it with traditional matching technologies so that everybody has a complete picture of the story, and then we'll certainly turn this over to Q&A after that, and I'm hoping there's a good number of questions. So, conventional MPIs don't use referential matching. They use an algorithmic-only technique called probabilistic matching. The best of them do. The not best of the traditional ones use rules-based matching, but in any event, they're limited to just mathematics, just algorithms. And specifically, the algorithms operate on the data, and if the data that they're operating on is bad, then the algorithms can only be just so good. There's a fundamental limit to the amount of errors that they can see through. And of course, as I mentioned earlier, they're kind of difficult to deploy and maintain and to change over time because they require so much tuning. By contrast, referential matching is different. In fact, referential matching is based on the idea that there's a very, very large and complete reference database. And that's where the word referential comes in. And this reference database acts as an answer key. It acts as a reference of all the identities that could possibly enter the hospital system with a full spectrum of identity data about each one of these individuals. So combine that gigantic reference database with a new kind of algorithm that takes into account the fact that there's a reference database, and you can do hypothesis testing against the reference database, you can make much better match decisions, or your technology can, I should say. And then if you add to that the third leg of this story, which is that it's all cloud-based, makes it so that this gigantic reference database can be continually updated, and those updates can feed your systems, feed the hospital's matching decisions, and it's easy to deploy at relatively low cost. So let me talk about this technology and the reference database at first, and I'll talk about how it uses it, the system uses it for matching. But the reference database that we're talking about is populated with identity facts about people, and those identity facts come from outside of healthcare. In fact, they're commercially purchasable by companies that can prove proper use and proper care. So both security and uses have to be completely within the bounds allowed by privacy and law. But the Verato reference database is populated by several major data sources, one of which comes from the credit industry, one from the telecom industry, and one that's an aggregation of governmental and legal records. But these billions of identity records flow into the reference database, and through very careful engineering, form a complete picture of the population here across the United States. And this data, as I mentioned earlier, is updated every month. But also very important to know is that the identity data, the names of people and their addresses, the database contains a historical picture. So it can go backwards, upwards of 30 years for people who've been around that long, or had an economic footprint in the U.S. for 30 years. So that it's no problem matching an identity of somebody as they were known 10 years ago to how they're known today. Married with a move, multiple move changes, married name, then a reversion back to a maiden name. All of this stuff is easily referenced and captured within the reference database. And in fact, the only way to build a picture of somebody, an accurate picture, is to not just collect data from sources, but to assemble it with very, very careful efforts of data scientists, the kind of PhDs that hospital systems typically can't employ, but a company like Verato can, and in so doing, we can use the latest technologies to form very comprehensive and complete pictures of people's identities as they change over time, which is what this spiderweb-looking representation in the middle of the United States is meant to represent. That's a single person with a bunch of identity data associated with them, and the concentric circles there are just how their data is changing over time. So with this complete picture, a referential matching system can do things that a pairwise EMPI or probabilistic matching system can't do. And that's what this slide's going to illustrate for you. On the left-hand side is traditional matching technology, where you have identity A and identity B, and let's say those are the same persons. They're both Mark LaRoe. It's just database A has me as Mark LaRoe at an old address and my phone number, and identity B has Mark LaRoe at a new address and not my phone number, but my social security number, for instance. Well, a probabilistic system or an EHR or EMPI matching system, in trying to determine if those are the same persons, they would overlay all of those elements, and if they overlaid perfectly, then it's obviously the same person. A and B is the same person. But if there are discrepancies, minor discrepancies that can't be explained through a simple misspelling or a nickname, or major discrepancy like a complete difference in address, then an MPI or an EHR system could never match those two people. But by contrast, on the right-hand side, if you have the same example, person A and person B, and they're the same person, but again, they don't overlay against each other very well, instead of overlaying A directly on top of B to see if they match, with referential matching, what you do is you overlap A with the reference database and you find the reference, and then you overlap B, and if both A and B map to the same reference identity, which has a much greater spectrum of data, but if A and B map to the same reference identity, then they map to each other. And it's almost not more complicated than that. If you have a really good answer key of identity data, you can make matches with referential matching that you could never make with traditional EHR or traditional EMPIs. And just to illustrate this one other way with some actual names and street addresses, again, with traditional EMPI or EHR matching, we have Catherine Smith on the left, and we have Kat Johnson, person B on the right, different addresses, a different a birthday on the left-hand side, but a phone number on the right-hand side. That data would never overlap, and an EHR or an EMPI would never consider those to be the same people. But a referential database would have Catherine Smith and Kat Johnson as both being valid names for the same person. And both of those addresses would be in her record in the reference database. And so you can see Catherine Smith maps to the appropriate data elements, Kat Johnson maps to the appropriate data elements, and therefore they map to each other. So ultimately, if a referential matching system is in the cloud, so if it's fast and easy to implement because it's in the cloud, if it's simple to connect to using standard open APIs, and if it's highly secure, HIPAA compliant, high trust, SOC 2 Type 2 certified, and it's scalable, able to support literally hundreds of millions of identities and real-time transactions, then what you basically have available to you is an extremely powerful matching engine at a fraction of the cost, something that no individual hospital system itself could ever build, but now you can take advantage of one that has been pre-built for you. And in fact, I'll put this slide up and maybe one other that just illustrates the improvements or the uplift that you can get from a referential matching system. What this graph shows you here is, quote, the uplift of matching over conventional MPIs. And the way to interpret this is all of the matches that a conventional system wasn't sure of, if all those were fed to a referential matching system, the referential matching system can automatically adjudicate anywhere from 50 to 75% of the matches that your traditional system could not decide upon. So this isn't to say that referential matching is magic. It can't auto-resolve 100% of the matches, because sometimes there's things that are just far too ambiguous that even a reference database can't properly make a decision upon, and human judgment is still required. But the vast majority of matches that a non-referential system makes, a referential system can do, and it can do all the ones and it can do 50 to 75% that the probabilistic system can't do. So let me just summarize by saying what you all as professionals have the opportunity to do for your organizations is what Dave did at Axia Women's Health, which is basically become a hero to solve a problem that historically has seemed insolvable. And if not insolvable, then at least solvable, but at extraordinary cost. Here you can solve it much more cheaply and much more accurately by using next generation technology. So I'll, in this very patriotic theme, I'll say, encourage all of you to be a hero, join this revolution in patient matching, and check out this new idea of referential matching. The way to do it is there are two different products that we offer. One of them, the one on the right, is an entire MPI product. It could be used as a replacement for any existing MPI that you might have. This is what Axia is using with Verato. But if you're not ready to swap out your existing MPI product, or if your EHR system has an MPI capability that's so deeply embedded in the workflow, like Epic or Cerner, you can still make use of the product you see on the left-hand side, this thing called Auto Steward, which does an automatic stewardship of potential matches that normally would all be sent to human beings. But instead of sending them to human beings, these now can be sent to Verato, and Verato can auto-steward all of the identity matches that your existing MPI system is not sure of, basically turbocharging your existing MPI. So now you can answer those questions that are being asked to you of the patients and the CEOs and the general counsel and the CIO and the CMIO and the CFO, all of whom have different new demands on the patient matching technology. You can implement this referential matching and just say you're welcome. With that, let me turn the podium back over to Lindsay, and we can take questions and answers for the next 10 minutes or so.
Thank you, Mark. We will now move on to the Q&A portion of the webcast. Audience members can submit questions using the question tool to the left of the screen. Mark and Dave, there are a couple questions that have come in during the event, so I'll start off with those. Dave, how long did this project take, and how many people did it require?
Well, we began working on this challenge back in March of 2018, and due to extreme deadlines that we had, we were pushed to finish it by the end of April of 2018. So it wasn't very long at all, just a little under 2 months, I believe, for us to perform our initial cleanup. From there, we took a little bit more time to implement the organic process to be safe, and we wrapped that up somewhere around August. So from beginning to end, March to August, so probably approximately 5 to 6 months tops. And as far as resources involved in this, it was myself with one other team member working on this in terms of the technical integration and implementation, and probably about a dozen people to help us validate and make sure that it was doing what we expected it to do before we went ahead and put it into production.
Great, thanks, Dave. Another question for you. Do you use Verato? So if Verato has a newer address for a patient that you have, would you be able to update it into your system, and would you store info that you didn't have?
That we do not do. As far as I know, and Mark can probably speak to this a little bit as well, the information that we send to Verato, they compare it for us and tell us whether or not it's the same person, but we don't supplement our existing information with any information from the referential data.
Yeah, I'll just add to that. Yeah, the reference database is continually updated through our data sources. And so what Axia and all of our other customers get to do is, in every one of their matching questions, every match request is tied to the entire spectrum of Verato data. And so it's all applied in real time to every new request that comes in. And that's how we make sure that our customers' matching capability is in essence evergreen and up to date.
Okay, great. I see that your technology works with eClinicalWorks. What other technologies does it work with?
I guess that would be for me. So, at Axia, their EHR was eClinicalWorks. We have other customers for whom we've integrated with Epic, certainly, Cerner, Allscripts, I think, are the 4 EHR products to which we are currently integrated. But because we're standards-based, we can literally integrate with everybody who supports the HL7 protocol suite, and we're moving to FHIR like the rest of the world is, but at a modest pace.
Okay, great. What kind of maintenance and upkeep has this project required, Dave?
Well, since the Verato services are cloud-based, we don't have to even really consider or worry about upkeep in that capacity. And since we already had existing interface systems for eClinicalWorks in place, no new components had to be added, so no additional IT upkeep on that. About the only thing that I would say is additional at this point is making sure that any kind of manual overlay detections that need to be reviewed are now being processed by somebody, but that is still significantly decreased over the processes that we used to have to do just to handle merge requests coming in. So overall, very little maintenance, very little upkeep.
Great. Mark, how do you integrate, and do you integrate using standards?
Yeah, I answered this just a moment ago, but I'll just elaborate. Yeah, so we have an API set. It's open interface, but and some people integrate with Verato using our native APIs, a RESTful API, so it's the modern interface. But we also have a full bevy of HL7 standard interfaces, because that's what all the clinical systems that we connect to currently use. And so in that regard, we're not just connecting to existing EHR systems, but we either supplement people that have IBM Initiate, or we supplement people that are running NextGate, and we supplement people that are running MirthMatch, again, using these open interface standards.
Thanks, Mark. Next question, is Verato pinged at every point of data entry into the system to verify patient identity, or is there a first pass on resolution locally?
Yeah, let me try and answer that one. We look at every data point that a customer presents to us. Sometimes it's incredibly sparse. Sometimes it's just, name, address, and birthday, or sometimes it's just name and address. And the tremendous value of a reference database is that because we have a picture of this name and this geography over 30 years, even given something as sparse in name and address, we can make matches because we can rule out that name ever living at any address or any location near that address or any name that looks like that name for the past 30 years. So even with sparse data, we can make matches that would be impossible to be made without a reference database. But to answer your question specifically, you said which data elements do we have, and do we do a first pass with fewer data elements? And no, we've got a real-time process that looks at all the data that the customer that is presented to our API. So every data element is looked at in the first pass, and not only is every data element looked at, it's compared to every data element we have for that person currently and back through history. And all that is done in one single pass and in real time.
Thank you so much. That actually concludes our webcast. Any questions that we did not get to, we will be sure to reach out to you individually. But I would like to thank our speakers, Dave and Mark, for their insights, our audience, and our sponsor, Verato. Thank you all very much, and goodbye.
All right, thanks, Lindsay. Bye.